All right, let's look at section 3 of our similarity unit. It has to do with perimeter, area, and volume of similar figures. As a review, we'll go over scale factor, which is a number that multiplies quantities evenly. For polygons, this multiplies the side lengths. So this rectangle is 2 times the size of this rectangle. So take these sides, multiply them by 2, and you'd get to this rectangle. That's the scale factor, is the number 2. It's 2 times as big. Next word, perimeter, the length around the outside of a figure. If I were to measure this length here, this length here, this length, and this length, add them all up around the outside of that figure, that is the perimeter. Now this is a one-dimensional measure. I'm going to show you what I mean by one-dimensional. It just goes in one direction. Okay, so if you just have a line, which technically this perimeter is just a line around the outside, when it's just one line, that is one-dimensional. So we use just units. Okay, so like feet or centimeters or miles. Area, on the other hand, is the amount of flat space inside of a polygon. So again, if this was like 2 feet over here, and this was 5 feet, we'd do 2 times 5, and there'd be 10 feet squared on the inside. There'd be like 10 little boxes that are 1 foot by 1 foot inside of this. Okay? Because this is a two-dimensional measure, we use units squared, or units to the second power. Two-dimensional squared. And again, this means not only are we looking at left and right, but we also have a up and down. So it might look something like this. 2 dimensions. Oop, I'm going to close that. 2 dimensions, left, right, up and down. Last one. Volume is the amount of space inside of an object. This is a 3-dimensional measure, so we use units cubed. So we've already done left and right. We've done up and down. Now we've got this kind of forward and backward look. This makes it 3-dimensional. We've got, I'm going to use different colors for this. Again, dimension 1 is just the left and right. Dimension 2 also has this up and down. And we go like this. Dimension 3 kind of goes deep or backwards. So there's 3 dimensions here when we're looking at volume. That's why it's in units cubed. So let's look at a couple example problems here. First off, before we get going, on this problem, the area of a triangle is going to be 1/2 base times the height. That should be a review, but we're going to use that while we're looking at these triangles. So for example 1, we're given that triangle ABC is similar to DEF. So these are similar triangles. They're not congruent, they're not the exact same, but they are similar. So what is the scale factor? Well, I'm going to do 2 different scale factors, one going from ABC to DEF, and that'll be in red. That scale factor would be 1/2. To go from 6 feet down to 3 feet, we multiplied by 1/2. And one way you can easily check that is just by putting this 3 over 6 and reducing that down to 1/2. Same thing, 5 over 10, reduce that to 1/2. Well, what if we went as a scale factor from DEF to ABC? Well, it would be just the opposite then. It'd be 2 over 1, which is the same as 2. So 3 times 2 gets you to 6. Or 5 times 2 gets to 10. And again, you could always find that by doing 6 over 3 or 10 over 5. That would reduce down to 2 over 1, which is 2. So our scale factor going from the bigger one to the smaller one is 1/2. If we were going from the smaller one to the bigger one, it would be 2. What is the perimeter of ABC? What is the perimeter of DEF? And how do these compare? Well, we are missing a length on both of these. But because they're right triangles, we can use Pythagorean theorem. A squared plus b squared equals c squared. So this one we have 6 and 10, and we're missing that hypotenuse. So 6 squared plus 10 squared equals c squared, which means 36 plus 100 equals c squared, which means 136 equals c squared. which means the square root of 136 equals c, so it's about 11.66. So we're going to write that in there. Same thing with our smaller triangle. We'll do the same thing. 3 squared plus 5 squared equals c squared. 3 squared is 9, 5 squared is 25. 9 plus 25 is 34. Take the square root of both sides, so the square root of 34 equals c, so it's about 5.83. So this one would be 5.83, and in fact that does fit our scale measurements. 5.83 times 2 would get us up to 11.66. Or going the other direction, 11.66 times 1/2, or 1/2 of this, is 5.83. So these still fit our scale factors. Now, to find the perimeter, we just add all of the side lengths up. So A, B, C, we would do 10 plus 6 plus 11.66, and it would be 27.66 feet. To find this perimeter, it's 5 plus 3 plus 5.83, and we get 13.83. Well, how do these compare? If we look at them, again, going from this perimeter to this perimeter, that's a scale of 1/2. We're going 1/2 the way down to get here. If we're going from this perimeter up to this perimeter, it's 2. So our perimeters are the same ratios, or the same factors as our scale factor was. Now we need to find the area of these pieces. What is the area of ABC? What is the area of DEF? And how do these compare? Well, again, area of a triangle is 1/2 base times height. So to find the area of ABC, here's our base, 10 feet. Here's the height at its tallest point, would be 6. 6 times 10 is 60, divided by 2, because 1/2 of it would give us 30 feet squared. Because it's an area, we have to do feet squared. Same thing with DEF. We would do 3 times 5 is 15, divided by 2, because it's 1/2 base times height, and we'd get 7.5 feet squared. Area is in feet squared because it's 2-dimensional. Perimeter is just feet because it's 1-dimensional. How do these compare? How does 30 compare to 7.5? Well, it's either a ratio of 1/4, 7.5 is 1/4 of 30, or going the other direction, 7.5 times 4 would get you to 30. Now notice, 1/2, 1/2, 1/4, 2, 2, 4. Scale factor and perimeter are the exact same. Notice how these ones compare to these ones, and we'll go over specifically what that means or how it does compare on a further slide. Example B, given circle A is similar to circle B. We have a few questions about that. As a review, circumference is pi times 2 times r. Area is pi times r squared. So what is the scale factor? I'm only going to do one scale factor this time so it doesn't get kind of messy. We're just going to go from the bigger to the smaller. Or actually, I guess it'd be from the smaller one to the bigger one. To go from B to A, you are multiplying by 5/2. This one is 5/2 as big as this one. So what is the circumference of circle A? What is the circumference of circle B? And how do these circumferences compare? Well, to find our circumference, remember again that it's pi times 2 times r. So for the circumference of A, pi times 2 times 5. There we go. That's going to be 10 pi feet. We're going to leave it in terms of pi, so we don't have to get the decimal numbers, but it's 10 times pi feet all the way around. 5 times 2 is 10, times the pi, all the way around. Same thing, circumference of B, 2 times 2 times pi, 4 pi feet all the way around this one. How do these compare? How does 10 pi compare to 4 pi? Again, that's a ratio of 5 to 2. So the scale factor going from this circle up to this circle, we're multiplying by 5 halves. And if you don't like that mixed number, that's 2.5. So this times 2.5 we get here. This number times 2.5 gets you here. It's going to be the same scale factor, the same ratio. Now, what is the area of circle A? What is the area of circle B? And how do the areas compare? Remember, area is pi times r squared. So we'll leave it in terms of pi again. One of our radius measures is 5, one of them is 2. So the area of circle A is going to be 25 pi feet squared. Remember, it's feet squared because it's two-dimensional. Area of circle B is going to be 4 pi feet squared. 2 squared is 4 times pi feet squared. How do these areas compare with each other? Well, it's not going to be 5 over 2 anymore. This is actually 25 over 4 is how these ones would compare. Now notice, like I said, it's not 5 halves, but if we took 5 and squared it, and took 2 and squared it, 5 squared is 25. 2 squared is 4. Also, what's interesting about that is this is in feet, this is in feet squared. So this squared comes from the fact that we're in 2 dimensions. We're using square feet, not just feet. If we were just using feet, it's 5 to 2. If we're using feet squared, it's 5 squared to 2 squared, or 25 fourths. Again, if you would rather use a scale factor that's not a improper fraction like this, this is going to be 6.25. So this number is 6.25 times as big as this number. Let's look at example C then. Given similar rectangular prisms. So these are, it's called a rectangular prism. It basically just means it's a box. Now, kind of an extra reminder here, surface area just means the sum of the areas of each face. So this box is going to have 6 faces, one on the front, one on the back, one on top, one on bottom, one on the left side over here, one on the right side. We would just add up all those all of those areas, and that would be the surface area of this figure. So first off, going from these two boxes, one to the other, what is the scale factor? It's 5. 5 times bigger. Box B is 5 times bigger than box A. What is the surface area of each figure? And how do the surface areas compare? I'm going to find the surface area on the right side over here. So again, we're finding 6 different faces and adding them up. Well, for box A here, we're going to have one face that's on the front and one that's on the back. That's this 5 by 16 right here. 5 by 16 is 80. There are 2 of them, a front and a back, so those would add up to 160 units squared. Also, there is a top and a bottom. Top and the bottom would be this 16 by 3. That would make this top area. 16 times 3 is 48 times 2, because there's a top and a bottom. So that'd be 96 right there. There's also 2 sides. These sides, as you can kind of see on this one right here, it would be 5 by 3. Would be that piece. 5 times 3 is 15 times 2, because there's a left one and a right one, would be 30. Add up 160, 96, and 30. And our total surface area would be 286 feet squared. So that'd be the surface area just of this box. In a sense, you can think of it, that's how much wrapping paper you would need to cover this box. Now for this box, it's a little bit bigger. It's 5 times as big, but we do the calculation's the same. We'll do the front and the back, so 25 by 80. Right here is 2,000 times 2, because there's a front and a back. It's going to be 4,000. There is a top and a bottom, so 80 by 15 would be this top piece up here. Is going to be 1,200. There's two of them, top and bottom, so times 2 is 2,400. And there are two sides, so we can see like this side here is 25 by 15. 25 times 15 is 375. Two of them, a left side and a right side, is 750. Now if we add up this 4,000, 2,400, and 750, the total surface area is 7,150 feet squared. So again, that's how much wrapping paper you need to go around the outside of this box. How do these compare then? Well, the surface area of this box, box B, is 25 times bigger. So just like in our last ones, when our scale factor was 5 times bigger, the area is going to be 5 squared. 5 squared is 25 times bigger. So although our side lengths go 5 times 5 is 25, 3 times 5 is 15, 16 times 5 is 80. So the scale factor is just times 5. The area factor is going to be 25, or this 5 squared. Now we need to find the volume of each figure. So that's how much space is on the inside of each box. To find that, it's length times height times width. So just multiply these three numbers. So the volume of box A is 5 times 16 times 3 is 240 feet cubed. We do it in feet cubed because it's 3 dimensions. Same thing with box B. We would do 25 times 80 times 15. And we would get that it would be 30,000 feet cubed. So these would be the two volumes. How do these two volumes compare? Well, the volume of B is 125 times bigger than volume A. How does this 125 compare to our 25 and our 5? We'll see that in our next slide here. The scale factor will always be the same as the ratio of the perimeters. I guess I should read off the question. What conclusions can you draw about how lengths, perimeter circumference, area, and volume of similar figures compare? The scale factor is always going to be the same as the ratio of the perimeters. So scale factor equals ratio of the perimeters. If you take the scale factor and square it, so like 5 squared, that'd be the ratio of the areas. 5 squared was 25. If you take the scale factor and cube it, so 5 times 5 times 5, that's the ratio of the volumes. 5 times 5 times 5 is 125, 5 cubed. This information right here is going to be very important for the rest of this unit. Make sure you understand and put a big star by this information. This is one of the main concepts that we'll be going over. And we'll shut it down there for our first video.